Hey everybody, welcome to the channel. In this video, I'll be using this material to 3D print this airframe that can fly like this. Thanks for watching. Please like and subscribe. And check out our website for this model and others, as well as printing configurations for different materials. The Igneous is a 3D printable 49-inch wingspan powered glider or worm liner. Printing files are available on the Sorcraft website. And for this build, I'm going to use the new 2-servo MH32 wing. Easier to program and easier to fly. I'm going to print it using the ColorFabb lightweight PLA-HT material and use the lightweight power pod and power system. First, let's talk through some of the most recent updates to the Igneous model. By far, the biggest change is to the tail section. The pushrod routing through the tail section is now a continuous tube with a gradual radius. This makes the pushrod assembly less finicky and should be smoother during use. Assembly into the fuselage midsection is now in the upper left quadrant, which lines it up perfectly with the servo under the wing. There are some other printing and feature enhancements for strength in several parts, but overall the airframe is mostly the same to print and build as before. There is a new lightweight power pod supplement with a shorter power pod for a lighter motor system I will be using in this build. These are all the parts that need to be printed. Most of them will be printed with the ColorFabb lightweight PLA-HT. It's a lightweight foaming 3D printing material that can handle higher temperatures after printing. But it's fall, much cooler out. Why would I bother with this material? I have found some additional benefits. First off, it's relatively easy to print, well, at least for my designs. With the right settings, just about any printer can print this material, no enclosure necessary. Second, at similar weighted parts, the ColorFabb HT material is surprisingly stiffer than the other foaming materials, and will only add about 25 grams to the total airframe weight, in this case, over using the lightest regular lightweight PLA. Lightness is not always best, and a couple grams weight penalty for almost double the stiffness is impressive. ColorFabb lightweight PLA-HT is more expensive, but the heat tolerance, ease of printing, and stiffness benefit might be worth the added expense for some applications. Though you don't need a new fancy printer for this, I highly recommend the new generation of devices. They are so good. The speed and part quality is amazing, and they are not outrageously priced. Bambu Labs has a nice range of products that are top-notch. All of these parts were printed with my Bambu Lab X1C, but I get similar results when I use the Bambu Lab A1. For part slicing, I primarily have been using Bambu Studio and PrusaSlicer. PrusaSlicer works similarly, it just doesn't work with Bambu printers. Configuration files for the X1C and P1S for the ColorFabb material are available on the website and will import into Bambu Studio or PrusaSlicer. See my other video for setting up other printers in PrusaSlicer. And I highly recommend tuning your settings to your printer with a test part before getting started printing any other parts. It's small and quick to print, but has all the necessary features. It's a much faster way to see what effect any changes you make have on these features, and still work as intended with the new material. Once happy, you can print the rest of the parts. With Orca, Bambu, and PrusaSlicer, you can import all of the parts into one project and set them up to print one at a time. You can save this project and come back to it whenever you want, and slice and print out all the parts. I have all the fuse parts on one build plate and the wing on another. For the wing panels and fins, change the seam location from back to nearest to get the cleanest parts with the foaming materials. The least visible travel moves usually make the best parts because the nozzle follows the inside surface of the part, but there may still be some strings on the inside. The skin should be nice and the carbon easy to slide through the passages, though some filing might be needed here and there. There are some little pieces in the servo covers that are best printed from regular PLA and can be printed all at once. There's a complete list in the instructions of all the required parts. Here are all the parts for the fuselage. The instructions have these and the carbon pieces and the regular power system pieces listed. However, we're going to use the instructions for the lightweight power pod system for this build. I used flat spray paint to add some color. Test fit all of the fuse parts together. Add the 1 meter long longerons. They should stick out the front a little. Mark and cut off the excess. The excess is used for the top carbon supports, which go all the way to the motor mount point. Test fit both sides. Mark and cut off the extra. I do this so I don't have to figure out the length differences for the different noses, different tails, and different fuse parts. And the longerons are the right length every time. Cut the tail carbon strips. They are pretty much the same every time. Test fit in the tail, and a center mark helps with centering. For the vertical carbon, mark the length and cut. Once inserted, it should be flush with the top. Test fit the T-tail finisher. Test fit the horizontal fins. Now for the elevator control horns. Sand the centers so they sit together nicely. Test the carbon fit. Drill one side for the screw, which should be a slip fit. With the easy connector assembled onto the horns, add it to the push rod. And then add the elevator carbon support. Add threads to the T-nuts, and then you can use the bolts to help insert them. Add the latch to the power pod door. I use a servo screw with a sharp tip cut off for the retainer. Then fit check the door. Now that all the printed parts and carbon are dry fit together, test fit the motor system and the elevator servo. The reference balance point for the finished fuselage is about 15 millimeters back from the center of the front wing bolt. I can then test out where I want my ESC and battery to be so I can get close to this balance point. I have a couple different battery sizes to try. And it's easy to adjust something now before I add any glue. And this is just to get it close. Once you're happy with the fit of everything, remove all the electronics and get ready for some glue. Separate the fuselage parts on the longeron so that there is space between to work. Remove all of the tail parts, leaving the carbon and the pushrod. But make sure the pushrod is still in the right place with the parts separated. This is the super thin CA we're going to use to glue everything together. A paper towel on the work surface to catch drips, and fold it in half. It's less likely to glue itself to the work surface. Start with the front of the fuse. Get the front of all the carbon rods about where they need to be. Tack in place with a couple drops of glue each. Then a couple of drops each down the length. This should anchor them in place for the rest of the build. Usually, if they don't spin, then they are ready to continue. Well, I didn't wait long enough, and this one, well, it moved a little. If I had noticed it at this point, I could have fixed it. That's okay, I can fix it later, and the other three are good. So continuing with the gluing, each joint front to back. Slide the parts together completely so they are straight and the seams between are uniform. Glue the T-nuts. Drip glue down the longerons between each joint. Check that the pushrod is still free or at least in the right place. Then glue the joint. Repeat for the mid to tail joint. Finally, drip glue from the back of the fuse. A couple of drips down each of the longerons will wick down the length. Center and align the horizontal tail carbon. Check that it is square to the vertical as well as each other. Tack in place with a little glue. Adjust if necessary. Then glue both sides. If the pushrod sheath is where you want it to be, glue it in place starting at the tail. A couple of drops. Make sure the rod still moves. I left the sheath long in front so I could glue with CA, but epoxy on a stick works too. Any glue on the inside will ruin your day. Couple drips of glue on the vertical carbon support. Check for drips, then set the fuse aside to let it dry for a minute. While you wait, you can get the horizontal fins ready. Score with a file on the bottom side to get the hinges ready to activate. Bend the elevator back and forth until it moves easily. This ColorFabb HT material works well for the hinges like these, but still a good idea to cover them with silicone. This is just a standard exterior grade silicone, and it's clear. Very flexible, good stuff. Clear any big chunks if it's an older tube. Then you're just adding a thin layer on each side. Wipe off excess with a finger. This encapsulates the whole hinge line, but doesn't need to be very thick. If it is too thin, you can add more. If it's too thick, you can relieve with a blade later. I will use the same method with the ailerons. And I've tested these silicone hinges well over 100 miles an hour, and they work great. Do both fins and set aside to dry for a few minutes. Exercise them a little before they are fully dry. Back to the fuselage. Pull the elevator pushrod wire forward and add the tail finisher over the sheath. Glue in place. Both sides. Cut the sheath flush. A sharp knife makes this easy. Extend the pushrod wire back out. Add the elevator control horn assembly to the exposed pushrod. Add the elevator carbon to the control horn assembly. Work the elevator hinges a little before installing. Then add the horizontal fins to the carbon. Use the center mark on the elevator carbon to eyeball that it remains in the center when pushing the tail fins together. Add a binder clip to make everything straight. Looks good. Then add some glue, a little on the top, a drop in the middle of the control horn. Then flip it upside down and put a nice bead on the bottom side of each seam. Both sides. This will wick out to the carbon. And a drop on the horn edge on both sides. Remove any excess and do not get any glue on the screw or the EZ connector. If you do, acetone can help debond any glue in the wrong place. Clean up any drips. And after a couple of minutes, remove the clip and check the elevator movement. And set aside to fully dry and build the wing in the meantime. These are all the parts for the wing build. The pieces are described in the instructions. However, the instructions are for a one-piece wing which is stiffer. But I'm going to build a two-piece wing, which is easier to pack, and the spar is removable to use on other wings. I already did an extensive two-piece wing build for this 2-servo MH32 wing. Link in the corner and in the description below. This will just be the highlights. The only difference in the parts is cutting the CS4 strip in half. Test fit the carbon strips and spar. Should be a slip fit. Trim, file, and sand the parts so they fit together. Parts in this material only needed minor cleanup. Test fit the whole wing half together. Mark the carbon depth for the wingtip. Slide the carbon into the wingtip and get it ready to glue. Drip glue down the carbon strips, but not the round spar. Let it dry enough to anchor in the tip panel. Then slide the next panel down. Check the gap. Add a trailing edge clip and repeat on the next panel. When the carbon strips are all glued, remove the spar. Then glue every seam top and bottom. Once dry, free up the aileron ends. Score the hinge line with a file. Work the hinge back and forth. Then add a thin layer of silicone, top and bottom. Feed the servo wire through the wing panel. Fit and test the servo. Add the control horn and screw and hot melt in place. Add the push rod and the EZ connector. Use more hot melt to add the servo cover and screws in the corner to secure. Build the other side the same way. You can watch the longer version if this was too fast. Now the fuselage is dry, I can fix my carbon mistake and add all of the electronics. Remove the pushrod and cut the sheath to where you want it. Install the servo. Flex the elevator hinge. You can score sections of it if it's too stiff. Add more if too thin. It should be relatively easy to move. I prefer a Z-bin on the servo horn. It gives good range of motion. Add the push rod back to the sheath and through the EZ connector and the horn on the servo in the mid-range position. Mark the push rod excess sticking out. Move the servo or remove the horn so that the mark can stick out farther. Cut off the excess at this mark. Add the screw to the servo arm. Make sure the servo is in the neutral position. Lock in the easy connector on the elevator control horn. Then test it out. Time to add the motor and the 4 mounting screws and nuts. Make sure all 4 are tight. Secure the propeller and the nose cone. Add the ESC. Now we're ready for the wing and the receiver. Hook up all the servos and the ESC. I have my receiver antenna back away from the ESC when inserting it under the wing. Secure the wing with the 4 wing bolts. And now add a battery and test it all out. Yay, it all works. Now I need to charge the battery and do final programming. Elevator throw high rate. Elevator low rate. And just a hair of up trim to start. Ailerons high rate. Ailerons low rate. And flaps can go down to 45 degrees. I also decided to add a vent hole to the door to help cool the ESC that sits right under it. Easy to cut, but I actually modified in CAD and printed another one. Very important last step is to check and adjust the CG. There are marks under the wing at the CG point to help with this. I ended up adding a couple grams of lead to get the CG just slightly nose heavy. I'm pretty happy with this build. Let's go see how it flies. So I'm at my nearby park on a nice calm fall day. Pre-flight check. Everything looks good. Let's do it. I probably could have pointed it up a little more, but the launch was rock solid and I didn't need to trim it at all. And even with the weaker power system, it gains altitude quickly. And is still pretty zippy. Controls are nice and crisp. This airframe can handle a lot more power. It flies really nice. So let's see how it lands. I was slowly adding more flaps. Oh, that might have been too much.
Safe.
That was pretty good, but I bet I could do better. Oh.
Nice.
I'm super happy with how this Igneous build came together and how it flew. The Igneous made from the ColorFabb Lightweight PLA-HT has some really impressive qualities, and I'm excited to fly it some more. and try out an alternative 3D printable folding prop and some new lightweight motors that can handle more RPM and more voltage. Files for the Igneous are available on the website. Thanks for watching, and I'll be back in another video soon. Oh, I got it dirty!